Imagine a team of scientists gathered in this sterile quiet of a control room, their faces illuminated by the glow of data streams from deep space. For weeks, they have been tracking an object, a visitor from beyond our solar system. The numbers coming back are clean, the signals strong, but they make no sense. The object is behaving as if the fundamental laws of physics have been temporarily suspended just for its benefit. It's venting colossal plumes of gas and dust into the void, yet it remains perfectly, unnervingly still, like a cannon firing a heavy shell but experiencing absolutely no recoil. The data is so wrong, so profoundly impossible, that the first conclusion they reach is the only one that seems logical. Their multi-billion-dollar instruments, the pinnacle of human engineering, must be broken. They run diagnostics, recalibrate, check and recheck their work, only to arrive at the same chilling realization. The instruments are fine. The data is real. The object, however, is not supposed to exist. What do you do when the universe sends you a puzzle that seems designed to break your understanding of reality itself? To find out and to join us on more journeys into the heart of the unknown, make sure you're subscribed to the channel. Now, let's begin. The story starts on a specific day, October 3rd, 2025. On this day, as our own world continues its familiar spin, multiple human-made spacecrafts orbiting the planet Mars are performing a delicate, coordinated dance. They are turning their sophisticated cameras and sensors away from the red dust of the Martian surface and are now explaining it to you because they are genuinely excited about it. They're not lecturing. They are sharing a moment of discovery. Their expertise is evident, but it's wrapped in a familiar, easygoing manner. Their target is a singular point of light, a traveler that has journeyed for millions, perhaps billions of years through the interstellar darkness, only to arrive in our cosmic neighborhood at this precise moment. This object is known to science as 3I Atlas. The 3I signifies that it is the third interstellar object humanity has ever detected. The first was the strange pancake-shaped Oumuamua. The second, 2I Borisov, looked more or less like a typical comet. But this third visitor, Atlas, is different. It is the first one that has made sober, serious scientists begin to question whether they are looking at a simple comet or something else entirely, something pretending to be one. Today, October 3rd, marks a critical juncture in the story of 3I Atlas, a moment that astronomers have been anticipating for months. At 4 o'clock this morning, Universal Time, the object made its closest approach to any planet during its entire passage through our solar system, skimming past Mars at a distance of just 29 million kilometers. In cosmic terms, this is a stone's throw. And for the spacecraft we have stationed there, it is an unprecedented opportunity. For the last 3 months, our view of Atlas has been frustratingly limited. We've watched it from Earth using our most powerful telescopes. The Hubble Space Telescope captured its faint light. The James Webb Space Telescope painstakingly analyzed its chemical signature. Dozens of observatories across the globe have tracked its every movement. But all of this data is hampered by one insurmountable problem: distance. When Hubble took its first photograph of Atlas back in July 21st, the object was a staggering 446 million kilometers away. That's about 3 times the distance between the Earth and the Sun. At that immense range, even an instrument as powerful as Hubble can only reveal so much. The image it produced was a fuzzy, indistinct blob, a nucleus shrouded in a ghostly cloud of dust, offering more questions than answers. But today, that has all changed. Our robotic emissaries at Mars are providing a new perspective. The Mars Reconnaissance Orbiter, equipped with its legendary high-resolution imaging science experiment, or HiRISE camera, is now 20 times closer to 3I Atlas than Hubble was. 20 times! The potential leap in clarity is difficult to overstate. Where Hubble saw a smudge of light, HiRISE should be able to resolve details down to just 30 kilometers per pixel. If the object's core, its nucleus, is as large as some of the early calculations suggest, perhaps 5 kilometers in diameter or even more, we are on the verge of seeing its true form. We should see its structure, its shape, maybe even the texture of its ancient surface. This is our first chance to truly meet our interstellar guest face to face. The Mars Reconnaissance Orbiter is not our only eye in the Martian sky. The European Space Agency, or ESA, has also tasked its own assets with observing this strange visitor. Two of their spacecraft, the Mars Express and the ExoMars Trace Gas Orbiter, have temporarily abandoned their primary missions of studying the red planet. They have turned their instruments outward, aiming at the far more unusual target passing through their cosmic neighborhood. The Mars Express carries what is known as the high-resolution stereo camera, while the ExoMars Orbiter is equipped with the color and stereo surface imaging system. Both of these instruments were meticulously designed to photograph the Martian landscape in stunning detail, to map its canyons and craters. But for this brief, fleeting window of opportunity, they're being used for a purpose their designers never envisioned: deep space astronomy. And it's not just about taking pictures. Both orbiters are equipped with a suite of incredibly sensitive instruments called spectrometers. The Mars Express has its Omega and Spicum instruments, while ExoMars has Nomad. These devices don't just see light, they dissect it. They work by breaking down the faint light that is either reflected or emitted by an object into its constituent wavelengths, its fundamental colors, creating a unique spectral fingerprint. This data is a treasure trove of information. It reveals the object's chemistry, telling us precisely what molecules are present in the gas and dust streaming from its surface. It can measure temperatures, and it can help scientists determine whether the activity we're seeing is being driven by the simple sublimation of ice, as one would expect from a comet, or by something else entirely. The official hope, the stated goal of this Mars moment, is to finally settle some of the most basic and perplexing questions about 3I Atlas. How big is its nucleus really? Is the object rotating? And if so, how fast? What does its cloud of dust and gas actually look like from up close? And most importantly, is this simply an unusually large and active comet that's behaving in strange ways? Or is it something fundamentally different? Herein lies the central tension, the core of the mystery that has kept astronomers awake at night. When 3I Atlas was first discovered back in July, its sheer brightness led to an astonishing initial estimate for its size. Based on how much light it was reflecting, astronomers calculated that its nucleus could be up to 20 kilometers in diameter. This would be a true behemoth. As more sophisticated instruments, like those at the Vera Rubin Observatory, brought their focus to bear, that estimate was revised downward, first to 10 kilometers. Then, after observations from the Hubble telescope in late July, the number shrank again to a more modest, yet still very large, 5.6 kilometers. Some models, which make different assumptions about how reflective the object's surface is, suggest it could be as small as 440 meters across. That is a colossal range of uncertainty, spanning from the size of a large building to the size of a small city. And the answer to this question matters immensely. If 3I Atlas is confirmed by the Mars observations to be 5 kilometers or larger, it would instantly become the most massive interstellar object ever detected. And not just by a little, but by several orders of magnitude. For context, the very first interstellar visitor, Oumuamua, was thought to be a mere 100 meters long. The second, 2I Borisova, was a more conventional-looking comet with a nucleus estimated to be around 600 meters in diameter. But an object that is 5 kilometers wide, with an estimated mass of 33 billion tons, isn't just big, it's statistically problematic. Our current understanding of how solar systems form and evolve suggests that for every massive mountain-sized object that gets ejected into the void between stars, there should be tens of thousands, if not hundreds of thousands, of smaller, pebble-sized fragments. The laws of probability are heavily weighted towards us detecting the smaller objects first, simply because there should be vastly more of them out there in the first place. Yet, here we are. With only 3 confirmed interstellar visitors to date, the third one is potentially 1,000 to 1,000,000 times more massive than the first two. That is completely backwards. The baffling statistics surrounding the size of 3I Atlas leave us with a set of uncomfortable possibilities. The first is that our models are simply wrong. Perhaps the galaxy isn't just lightly dotted with interstellar debris, but is absolutely swarming with it, filled with far more large objects than we ever imagined. This would imply that the processes that eject material from developing solar systems are fundamentally more violent or efficient than our current theories allow. A second possibility is that we have just been extraordinarily, impossibly lucky to have detected such a rare giant so early in our search. The third and most unsettling possibility is that this object isn't natural debris at all. This is the central question that the observations from our Martian spacecraft are supposed to help us answer. If the HiRISE camera captures a clear image that shows a solid nucleus 5 kilometers wide, then the mass estimate of 33 billion tons becomes a hard, undeniable fact. At that point, the statistical anomaly becomes a full-blown crisis in planetary science. On the other hand, if the image reveals something much smaller, say a kilometer or less, then the mystery simply shifts its form. A smaller nucleus producing such an enormous bright cloud of gas and dust would mean the object is hyperactive, venting far more material than any known comet at its distance from the Sun. Either way, something about 3I Atlas simply does not add up. And to compound the frustration, we won't get our answers immediately. The immense amount of data captured by the orbiters has to be transmitted across millions of kilometers of space back to Earth. Once it arrives, it must be painstakingly processed, analyzed, and cross-checked by teams of scientists. The European Space Agency has already tried to manage expectations, stating that they don't anticipate spectacular images from their two orbiters. Those orbiters were designed to look down, not up, and at a distance of 30 million kilometers, Atlas will likely appear as less than one single pixel in their cameras. HiRISE is our real hope for a clear picture, and even then, the timeline for releasing a processed image is uncertain. It could be days, or it could be weeks. While we wait for the images from Mars, 3I Atlas continues its silent journey onward. In just a matter of days, by the middle of October, it will draw too close to the Sun to be observed from Earth. The overwhelming glare of our own star will render it completely invisible to our telescopes. It will reach its perihelion, its closest port to the Sun, on October 29th, at a distance of 1.4 astronomical units. That's just inside the orbit of Mars. For that entire period, from mid-October through the end of the month, the object will be on the opposite side of the Sun, hidden from our view. This blackout will last for 26 days. For nearly a month, it will be gone. When it finally reemerges into our view in early December, appearing as a faint smudge in the pre-dawn sky, we will have our next chance to study it. We will be able to check its trajectory again, measure its brightness, and confirm whether it behaved like a normal comet during its fiery passage around the Sun, or whether something unexpected happened while it was hidden from our sight. But let's return to today, October 3rd, this crucial Mars moment. Because while the official scientific narrative is rightly focused on resolving the question of the object's size, there is another deeper layer to this story. This layer has less to do with the images our cameras might capture and more to do with the bizarre data we have already collected. And it is here, in the cold, hard numbers, that the conventional explanations truly begin to break down. On the very same day as the Mars flyby, the Harvard astronomer Avi Loeb published an article. The timing was no coincidence. In it, he methodically laid out what he terms the 7 anomalies of 3I Atlas. He didn't call them curiosities or ambiguities. He called them anomalies, behaviors and characteristics that do not fit the standard model of what an interstellar comet should look like. He divided these 7 anomalies into 2 distinct categories. The first category contains 4 puzzles that could, at least in theory, be explained away with better data. But the second category contains 3 anomalies that, in his own words, will remain puzzling forever. The reason Avi Loeb considers the second category of anomalies to be permanently puzzling is that they are not about missing information. They're about probabilities. They're about trajectories and timings so exquisitely fine-tuned that they seem to suggest something far more profound than random chance. But let's begin with the first category, the 4 anomalies that might yet have a conventional explanation. Anomaly number 1 is its size. As we've discussed, the nucleus of 3I Atlas appears to be larger than 5 kilometers, giving it a staggering minimum mass of 33 billion tons. This makes it 1,000 to 1,000,000 times more massive than the 2 previous interstellar objects we've detected. The potential for a natural explanation here hinges entirely on what the new observations from Mars will reveal. If the nucleus turns out to be much smaller, the anomaly softens into a curiosity. If it is confirmed to be 5 kilometers or larger, the statistical problem deepens into a genuine paradox. Anomaly number 2 is what astronomers are calling the jet. Images from the Hubble Space Telescope show a peculiar and distinct feature, a narrow jet of scattered sunlight, 10 times longer than it is wide, that points directly towards the sun. This is highly unusual. Most comets display tails of dust and gas that are pushed away from the sun by the solar wind and radiation pressure, but this jet is oriented in precisely the opposite direction. The conventional explanation offered by astronomers is that Atlas is experiencing a powerful outgassing event on its sunward-facing side. This event releases a dense stream of material that brightly reflects sunlight before it is inevitably pushed back to form a more traditional tail. And that is plausible, but there's a catch. This strange forward jet appeared very early in its approach, at distances from the sun where most comets are still frozen and dormant, and it remained unusually bright and persistent for months. A faint, more conventional tail did eventually appear by late in August, but only after the object had moved significantly closer to the sun. That delay is odd. It suggests the outgassing dynamics of 3I Atlas are not behaving like a typical comet.
The third anomaly brings us to its chemical composition, and it is here that the story takes a turn for the genuinely strange. Spectroscopic observations, conducted by both the James Webb Space Telescope and the Very Large Telescope, have revealed that the plume of gas surrounding 3I Atlas contains far more nickel than it does iron. In all normal comets, and even in the previous interstellar comet 2I Borisov, nickel and iron appear in ratios that are similar to what we see in our own sun, that is, they are roughly balanced. But 3I Atlas shows an extreme and undeniable dominance of nickel. Nickel was detected in its spectrum at every single observation. Iron, on the other hand, only made an appearance when the object was closer than 2.64 astronomical units from the Sun, and even then, the ratio of nickel to iron remained far higher than expected. This might seem like a trivial detail, but it matters a great deal. Nickel and iron are what are known as refractory metals. This means they do not easily sublimate or turn from a solid directly into a gas at the extremely low temperatures found on the surface of a comet. Even as it gets relatively close to the sun, the surface of Atlas is far too cold for raw, solid nickel to simply boil off into space. Something else must be happening. The most likely explanation is the existence of a parent molecule, some unknown chemical compound containing nickel that is volatile enough to turn into a gas and then breaks down under sunlight, releasing the nickel atoms. The problem is, we don't know of any naturally occurring molecule that fits this description. And there's more. The composition of the gas itself is also highly unusual. The vast majority of comets in our solar system are water-rich. As they approach the sun, their water ice sublimates and dominates their spectral signature. But 3I Atlas is overwhelmingly rich in carbon dioxide. The measured ratio of carbon dioxide to water is 8:1, which is among the highest ever recorded. This strongly suggests that the object formed in an extremely cold environment, far colder than the regions where our own solar system's comets are born. The fourth and final anomaly in the potentially explainable category is a technical one, but it is critically important. It has to do with something called polarization. When sunlight reflects off the tiny dust particles in a comet's coma, the light becomes polarized. By measuring the degree and the direction of this polarization, scientists can learn a great deal about the size, shape, and texture of those dust grains. Over decades of study, we have learned that every comet at every asteroid in our solar system falls within a certain predictable range of polarization values. It's a consistent and reliable diagnostic tool. 3I Atlas does not conform to this pattern. When the first polarization data came back from the telescopes, the numbers were so far outside the expected range that the research team's initial reaction was to assume an error had been made. They checked their instruments, repeated the measurements, and got the exact same bizarre result. The only way to explain the numbers they were seeing is if the dust grains being shed by Atlas are fundamentally different from any cometary dust we have ever seen before. They're not typical silicate sand, nor are they simple water ice crystals. The data suggests they are large, highly complex particles with a porous, almost smoke-like structure. Now, these four anomalies, the massive size, the strange forward jet, the nickel-rich chemistry, and the weird dust, are all deeply strange. However, they are not necessarily fatal to the hypothesis that Atlas is a natural comet. It's possible that better data will show the nucleus is smaller than we think. The jet could be a rare but natural outgassing asymmetry. The nickel might come from some exotic parent molecule that we simply haven't discovered yet. The dust could be the product of unusual formation conditions in its own star system. All of these explanations are uncomfortable for astronomers, but they are, in principle, still within the realm of possibility. But then we arrive at the second category of anomalies, the ones Avi Loeb calls the permanent mysteries. Anomaly number 5 is its trajectory. The orbit of 3I Atlas is aligned with the ecliptic plane, the flat disk in which all the planets orbit the Sun, to within a mere 5 degrees.
Interstellar objects should arrive in our solar system from random directions in the galaxy. Their trajectories should be a scattershot, with some coming in at steep inclinations, some shallow, some even moving backward relative to the planets. The probability that an object arriving by pure chance would have a trajectory so closely aligned with our planetary plane is only about 0.2%. That's a 1 in 500 chance. Now, that's not impossible. Rare events happen all the time in a universe as vast as ours, but it is the first major red flag that suggests something about this visitor's path might be special. Anomaly number 6, however, is where the probability plummets off a cliff. 3I Atlas didn't just arrive on a trajectory that was neatly aligned with the planets. It arrived at the perfect time to allow for a series of close encounters with multiple worlds. It passed Mars today, October 3rd. It was positioned for a potential close pass of Venus with only a minimal course correction back in July. And its current path sets it up for a relatively close flyby of Jupiter in March of 2026. The probability of an interstellar object randomly arriving on a trajectory and at a time that allows for such a convenient grand tour of our solar system is about 0.005%. That's a 1 in 20,000 chance. Let that sink in for a moment. If you were an engineer designing an interplanetary probe to visit multiple planets, you would design its trajectory in exactly this way. You would want a path that efficiently intersects the orbital planes of your targets. You would time your arrival to coincide with their positions in space. You would do everything you could to minimize the amount of fuel needed for course adjustments. This is precisely how we design our own robotic missions, like the Voyager probes or New Horizons. We optimize the trajectory and use gravitational assists to hop from one planet to the next. The path of 3I Atlas looks, for all intents and purposes, like it was deliberately designed. It looks like it was delivered. This is the context in which 2 days ago, the entire story changed. On October 1st, 2025, an anonymous post appeared on the website 4chan. The post did not appear in a science forum nor on a server for academic preprints. It was posted to 4chan's paranormal board, a corner of the internet far more known for conspiracy theories and internet folklore than for legitimate scientific discourse. But the content of this post was not folklore.
The author claimed to be a PhD researcher who was currently working with the European Space Agency. They stated that they had ongoing access to the combined observational data for 3I Atlas, and that they were a member of a formal internal working group that had been tasked with making sense of this bizarre object. And, they claimed, that group had failed. The post began with a quote that speaks volumes about the level of frustration behind the leak. For months, I've been part of a formal working group that has tried and failed to reconcile this object's behavior with any known class of natural celestial body. The official position is that 3I Atlas is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us. Now, let me be perfectly clear. An anonymous post on 4chan is not peer-reviewed science. It has not been verified. It could very well be an elaborate work of fiction or role-playing exercise by someone who has simply read the publicly available papers and decided to stir up speculation. But what makes this particular post different is the sheer level of technical detail it contains. The palpable frustration in the author's tone feels genuine, and the specific claims it makes align disturbingly well with the data that is already public, while adding crucial context that has not appeared in any official release or scientific paper. So, I am going to walk you through what this person said as not established fact, but as a potential window into what might be happening behind the scenes when scientists are confronted with data that simply refuses to cooperate. The post starts with the topic of outgassing. We know that 3I Atlas is venting a tremendous amount of gas and dust, approximately 150 kilograms every single second.
This figure of 150 kilograms per second is not speculation. It is a measurable fact. The James Webb Space Telescope observed it directly. Spectrometers at the Very Large Telescope confirmed it. The object is hemorrhaging material, carbon dioxide, water ice, and strange dust grains constantly and violently. And according to this alleged researcher, this violent venting has absolutely no effect on the object's trajectory. Their words paint a vivid picture of the disbelief among the scientific team. It feels like a mistake in the data until you've checked it 100 times with all the available instruments. The object is venting about 150 kilograms of gas and dust every single second. We see it, yet it does nothing. It's like watching a howitzer fire a shell with absolutely zero recoil or smoke or bang. It's a constant, violent event with no consequences, and that is a disgusting violation of basic physics. Let me explain exactly why this is such a profound problem. When a comet releases gas from its surface, it should experience a tiny amount of thrust. This is a direct consequence of Newton's third law of motion. For every action, there is an equal and opposite reaction. As the gas jets away from the surface in one direction, the comet should recoil, however slightly, in the opposite direction. While this force is minuscule, it is measurable over time. It causes the comet to deviate slightly from a purely gravitational path, an effect that astronomers call non-gravitational acceleration. Every active comet we have ever studied shows this effect. Halley's Comet, Comet Hale-Bopp, and even 2I Borisov, the previous interstellar visitor, all displayed measurable non-gravitational acceleration as they outgassed near the Sun. 3I Atlas, however, shows almost none. There's a paper published in September that analyzed over 4,000 positional observations of the object from 227 different observatories. The authors calculated its trajectory with extreme precision and then looked for any sign of these non-gravitational deviations. The upper limit they were able to find was impossibly small. For an object venting 150 kilograms of material per second, the recoil is effectively zero. According to the anonymous poster, there is only one way the physics of this situation can work. The object must be far, far more massive than it appears. The post states, the only way the physics works is if the object has the mass of a small moon crammed into a space no more than 2 to 3 kilometers across. This aligns perfectly with the lower end estimate of 33 billion tons. But as the poster points out, solving the recoil problem with immense mass creates a second, even worse problem. Finding a mountain on an interstellar trajectory is statistically impossible. Think about what this implies. If 3I Atlas truly possesses enough mass to resist the recoil from its powerful outgassing, it must be incredibly dense. It would have to be far denser than ice, denser even than rock, approaching the density of solid iron. A 3-kilometer sphere of solid nickel iron would have roughly that mass. But we know this object is not a simple metallic asteroid. It has a coma and a tail. It is actively outgassing like a comet, which means it must have volatile ices on its surface. So the immense mass has to be there, but it must somehow be compatible with a fragile, icy exterior. The poster continues, capturing the sense of crisis this paradox creates. Our surveys have only just started. To find an object this massive, this soon, means the galaxy isn't just dotted with debris, it's swarming with them. The models are wrong by a factor of 10,000. Our entire picture of what gets ejected from solar systems is fundamentally, grotesquely flawed. Or, this object isn't debris at all. The post then drives home the gravity of this conclusion, and that is the quiet and terrifying conclusion we are being discouraged from discussing. Let that settle in. If the mass estimate is correct, our statistical models are shattered. Large interstellar objects should be exponentially rarer than smaller ones. And yet, of the 3 we've seen, the third is a monster. The sequence is inverted. Either we have been impossibly lucky, or our entire understanding of how planetary systems form and shed material is wrong on a fundamental level. Or there is the third option. This object is not natural debris.
But the problems don't stop with the physics of its motion. According to the anonymous post, the object's chemistry is just as nonsensical. The author writes, "You look at what's actually in the gas, it gets worse. We're seeing pure atomic nickel steaming off. It's happening at temperatures where it should be frozen solid. This isn't gradual like ice turning to vapor. It's a switch. The nickel production is insanely sensitive to sunlight. A tiny change in heat and it just shuts off." Then the post offers a chillingly specific explanation for this bizarre behavior. There's only one way you get that, a breakdown of a parent molecule. The only option is nickel tetracarbonyl, something we use in industrial refining. It explains everything, especially why there's no iron. But it's not a naturally occurring compound. What the hell is a synthetic chemical doing on a rock which we think has been in space for billions of years? Let's take a moment to understand what nickel tetracarbonyl is. It's a chemical compound with 1 nickel atom bonded to 4 carbon monoxide groups. At room temperature, it's a colorless, highly toxic, and highly volatile liquid. It was first discovered in 1890 by a chemist named Ludwig Mond, and it is used today in an industrial procedure called the Mond process to purify nickel metal. It is, for all intents and purposes, a synthetic compound created in laboratories and refineries. It does not occur naturally on Earth, and according to this alleged insider, it is the only compound that perfectly explains the nickel emission profile from 3I Atlas, the extreme sensitivity to temperature, the on-off switching behavior, and the conspicuous absence of iron. But if this synthetic industrial chemical is present on an interstellar object that is supposed to be billions of years old, how did it get there? Natural processes do not create nickel tetracarbonyl. It requires very specific conditions, namely high-pressure carbon monoxide gas interacting with metallic nickel.
And even if those conditions did exist somewhere in a distant, nascent solar system, the compound itself is unstable. It breaks down over time. It would not survive a journey of billions of years through interstellar space, unless it was being actively produced. The mystery of the object's composition deepens when we consider the iron. In all normal solar system material, nickel and iron appear together, typically in a ratio of about 1 nickel atom for every 20 iron atoms. This is the standard cosmic abundance. But 3I Atlas shows this extreme overabundance of nickel, with iron only barely appearing in the spectrum when the object gets very close to the Sun. The nickel tetracarbonyl hypothesis provides a neat, if unsettling, explanation. Iron does not form a comparable volatile compound as easily as nickel does. If the outgassing process on Atlas is specifically designed to produce nickel tetracarbonyl, then you would naturally see nickel without the accompanying iron. The chemistry is selective. But again, this implies an active, sophisticated chemical process, not the simple sublimation of ancient ice. The poster then shifts his focus from the gas to the dust. And the dust it's shedding is just as messed up. We measure how light reflects off it. Its polarization tells you about the texture of the particles. Every comet, every asteroid, they all fall within a certain range. This thing's data comes back so far off what's expected, our director insisted we were messing up for the best part of a week until we repeated the result. The only way to get these numbers is if the dust grains are something else entirely. Not sand, not ice. Large, incredibly complex particles, black and porous as smoke. It's not natural dust. It's a manufactured material. This claim that the dust appears to be manufactured is probably one of the most shocking in the entire post. We do have public data on the dust's polarization. The measurements show a value that is extremely rare, indicating that the light is being polarized in a way that only happens with particles that have highly irregular shapes and complex internal structures. The official scientific paper noted that this was unusual, but stopped short of calling it impossible. This alleged insider claims that the internal discussions went much further, that the team was so baffled by the numbers that they assumed their instruments were malfunctioning until repeated observations confirmed the impossible result.
Normal cometary dust is composed of small, simple silicate or carbonaceous grains, lifted off the surface as ice sublimates. But large, porous, smoke-like particles sound more like the byproduct of combustion or an industrial process, or something designed to break down a solid material into an ultra-fine powder. The post continues its litany of impossibilities by addressing the object's rotation, or rather, its complete lack thereof. Hubble and Webb see a feature that shouldn't exist, a faint, greasy smear of a tail pointing straight at the Sun. Supposedly, a massive carbon dioxide jet is firing from its sun-facing side, powerful enough to lift heavy water ice grains that sunlight can't easily push away. A violent, directional engine. Okay, fine. But it isn't rotating. We've stared at it for days on end. Its brightness doesn't change, not by a fraction of a percent. It's a dead, flat line. This is a subtle but critically important point. If an object is rotating and it has a powerful jet firing from one side, we should see its brightness flicker periodically as that jet rotates into and out of our view. This is standard behavior for comets. Their brightness curves rise and fall in a predictable rhythm. According to this researcher, 3I Atlas shows no such rhythm. Its brightness is constant, stable, and dead flat. This implies one of two things. Either the object is not rotating at all, which is almost impossible for anything that has traveled through space for billions of years, or its brightness is somehow constant because its outgassing is perfectly symmetrical, happening equally in all directions at all times. But a perfectly symmetric outgassing pattern cannot explain the forward-pointing tail. A tail like that requires directionality, an asymmetry, a jet. So we are left with two incompatible observations, a tail that demands a jet and a brightness curve that demands perfect symmetry. The poster puts it bluntly, you can't have them both. One is a lie. Either the model for the tail is wrong or that cloud isn't natural.
The next paradox presented in the leak is the thermal problem. The Post explains, then there's the heat. The thing is cold. It's absorbing gigawatts of raw solar energy, enough to power a small city. We calculate the energy budget, and there's a massive surplus. That heat has to go somewhere. It should be driving off enormous plumes of water vapor, but the water isn't there. It's like pointing a blowtorch at an ice cube and watching it refuse to melt. This is a violation of one of the most basic principles in physics, the conservation of energy. For any object in space, the energy it absorbs from the sun must equal the energy it radiates away as heat, plus the energy it uses to sublimate its surface ices. That's how comets stay cool. Turning ice into gas is an incredibly effective heat sink. But if 3I Atlas is absorbing gigawatts of solar power, but is not releasing the expected amount of water vapor, where is all that energy going? According to this researcher, the thermal models simply do not balance. There is a massive surplus of heat that should be driving intense activity, but the expected emissions are not showing up in the data. One possibility is that the object's surface is highly reflective, but if that were the case, it should appear much brighter than it does. Another is that the heat is being conducted deep into its interior, but that would require a thermal conductivity unusual for an icy body. Or, as the poster suggests, the object has found a way to either dispose of or regulate an enormous thermal load to keep its surface locked at a specific low temperature. The word regulate again implies active control, a system, not passive physics. Finally, the post returns to the object's trajectory. And that's before you even look at the path it took to get here. Its trajectory is a statistical joke. It's a perfect low angular momentum orbit, the kind that guarantees a close path. The physicists who model this stuff are blunt. There is no known natural process that filters massive objects onto these trajectories. It wasn't just a random encounter. For all intents and purposes, this thing was delivered from the darkness.
The post culminates in a powerful, unifying statement that attempts to tie all these disparate, paradoxical observations together. You don't get it. None of these are separate problems. They're all symptoms of a single underlying sickness. A jet powerful enough to make the tail would make the object flicker. It doesn't. A body that massive should be dead. It isn't. The sun's heat should be boiling it alive. It feels nothing. Each paradox is a wall. And we're all standing here staring at the walls, refusing to see the shape of the room. This isn't a failure of our models. This is a glimpse of the machinery running underneath them. And it's wrong. That haunting phrase, a glimpse of the machinery running underneath, suggests that these anomalies are not bugs in our understanding, they're features of the object itself. It suggests that the object isn't broken, but is instead operating according to a set of rules that we do not comprehend. And then the researcher offers a single comprehensive explanation. It is an explanation that sounds like it has been pulled from the pages of the most speculative science fiction, but according to them, it is the only physics that makes the entirety of the data coherent. To understand it, we have to go back to the very first moments of the universe's existence. In the unimaginable heat and density of the Big Bang, the laws of physics as we know them had not yet solidified. It was a time of pure potential, a hot plasma where the fundamental forces were unified. As the universe expanded and cooled, it underwent a series of phase transitions, much like steam condensing into water and then freezing into ice. Symmetries broke, forces separated, and matter as we know it began to condense. But these phase transitions are not always perfect. Just like bubbles can get trapped in freezing ice, the rapid cooling of the early universe might have created defects, pockets where the old unified state of reality persisted, trapped, and stable within our own. These theoretical relics have names: cosmic strings, monopoles, and the one relevant to our story, cue balls. The anonymous post makes an extraordinary claim. 3I Atlas is a cue ball. The author writes, it is a macroscopic quantum object, a stable, massive particle left over from the first microseconds of the Big Bang, a bubble of a different set of physical laws that has managed to survive cloaked in a skin of our reality. They go on to state, this isn't a theory, it is the only known physics that makes the data coherent. So, what exactly is a cue ball? In theoretical physics, it is known as a non-topological soliton.
To put that in simpler terms, think of it as a stable, self-sustaining lump of energy. It holds its shape due to a perfect balance between the forces trying to make it dissipate and other forces trying to pull it together. It's not held together by the geometry of space, like a knot, but by a conserved quantity, a type of charge, which is where the Q and its name comes from. Certain advanced theories of physics predict that these objects could have formed in the chaotic environment of the early universe. They would be made of exotic fields that, in the right configuration, can create a stable, incredibly massive object. A cue ball is essentially a bubble where the fundamental field inside has a different value than the field of the universe outside. This bubble doesn't collapse because its state represents a local minimum in the landscape of potential energy. The key property of a cue ball, and the reason it is being proposed as an explanation for 3I Atlas, is that it is its own internal energy source. The exotic field trapped in the bubble is decaying, but at an infinitesimally slow rate, releasing a steady stream of energy over billions of years. That energy would manifest as particles, radiation, and heat emanating from the core. The cue ball would gradually lose mass over cosmic timescales, but the process is so slow that a cue ball formed in the Big Bang could easily still exist today. Now, this is highly speculative physics. Cue balls have never been observed. They are predictions of certain theories that have not yet been confirmed. But the alleged insider is claiming that 3I Atlas fits the profile of a cue ball perfectly.
Let's walk through the logic of the cue ball hypothesis and see how it claims to solve every single one of the anomalies presented by 3I Atlas. First, the problem of its immense mass in such a small volume. Cue balls are predicted to be incredibly dense. A 3-kilometer wide cue ball could easily contain the mass of a small moon, 33 billion tons or more. This perfectly matches the minimum mass required to explain the object's lack of recoil. Second, the problem of the recoilless yet violent outgassing. A cue ball's energy decay would happen at its core, releasing energy uniformly in all directions. This internal engine would heat any surrounding material, a mantle of ice and dust accumulated over billions of years of interstellar travel, from the inside out. This would cause the ice to sublimate perfectly symmetrically. There would be no localized jets, and therefore no directional thrust. The outgassing would be perfectly balanced, resulting in no net recoil. It elegantly explains the image of a howitzer firing with no kickback. The engine inside produces the gas, and the gas escapes equally in all directions. Newton's third law is satisfied because all the action and reaction forces cancel each other out. Third, the mystery of its constant brightness. If the outgassing is perfectly isotropic, or the same in all directions, then the cloud of dust and gas surrounding the cue ball would be spherically symmetrical. In this case, the object's rotation wouldn't matter. It would look exactly the same from every angle. Its brightness would never flicker because there would be no asymmetry to rotate into and out of view. It resolves the paradox of having a feature that looks like a tail without the corresponding periodic brightness changes. Fourth, the exotic chemistry. A cue ball's decay is not a normal thermal process. It is a high-energy particle physics event. The Post calls it a slow burn reactor that operates at a constant low temperature. Over billions of years, this quantum decay process could produce highly unusual byproducts, including complex molecules, metallic compounds like nickel tetracarbonyl, and the strange manufactured dust. They would be the exhaust of this ancient engine. Fifth, the cue ball hypothesis addresses the thermal problem, what the Post calls its thermal indifference. A cue ball simply wouldn't care about the sun. Its own internal energy source would dwarf the energy it receives from solar heating. Its surface temperature would be regulated not by absorbing and re-radiating sunlight, but by the steady, constant output of energy from its core. The gigawatts of power it absorbs from the sun would be, as the Post puts it, a trivial external variable. This explains how it can absorb so much energy yet remain cold, and how it can be so active without producing the expected plumes of water vapor. The sun is not part of its life cycle. Sixth, and finally, the trajectory. If cue balls are not rare, but are in fact a common component of the universe, perhaps even a form of dark matter, then the galaxy would be full of them. They would not be anomalous, they would be everywhere. 3I Atlas would not be a piece of debris ejected from a distant star system, it would be part of the very fabric of the cosmos, a relic from the Big Bang itself. This completely resolves the statistical problem of finding such a massive object so soon. We wouldn't be looking at ejected planetary material, we would be looking at the very fabric of the universe. The Post frames this as a terrifying revelation. The cue ball is the mass. Its engine is its own decay. The lack of recoil is no longer a paradox, it's a defining feature. This is not a matter of belief. This is the only known physics that makes the data coherent. Once you look at it, the entire system of wrongness snaps into a logical, horrifying picture. Horrifying, that is the word the author chose. Not intriguing, not surprising, horrifying. Why? Because if 3I Atlas is a cue ball, it means that dark matter isn't just some inert, invisible substance scattered throughout space. It is active, it is massive, and it is everywhere. The galaxy isn't just dotted with a few interstellar rocks, it is swarming with ancient, massive objects, each one a remnant of the Big Bang, and each one slowly decaying, and each one capable of wandering into a solar system.
But here's the most crucial part of this entire wild hypothesis. Unlike many grand sweeping theories, the cue ball hypothesis is testable. The Anonymous Post concludes not with philosophical musings, but with two specific, falsifiable predictions. The author writes, "Screen cap this." The first prediction concerns the object's activity as it moves away from the sun. The behavior of a normal comet is driven entirely by solar heating. As it moves away from the sun, its outgassing slows down and its brightness fades in a predictable way. Every comet we have ever observed follows this pattern. But if 3I Atlas is powered by an internal engine, its activity will not follow this pattern. As it recedes into the cold depths of the outer solar system, past the orbit of Jupiter and beyond, its brightness and its rate of mass loss should remain impossibly high. It will violate the fundamental thermodynamic expectation for a passive cooling body. This is something we can test. We just have to watch. When the object re-emerges from behind the sun in December, we will have months to observe it as it travels outward. If it stays bright, if its outgassing continues unabated, that would be a smoking gun. Comets simply do not do that. The second prediction is even more direct. It concerns high-energy emissions. A cue ball's decay is a particle physics event. The Anonymous Post estimates its energy output at 73 megawatts. That energy doesn't just disappear. It should produce high-energy particles, gamma rays and X-rays. This would create a non-thermal, high-energy signature that should be detectable by our space-based telescopes. The Post urges, point a gamma ray telescope at it. If you detect a signal that is not attributable to solar-wind interaction, you're not seeing a comet. You're hearing the heartbeat of an object that doesn't follow the rules of our physics. This is also eminently testable. We have gamma-ray observatories like the Fermi and Integral spacecraft that are constantly scanning the sky. No natural comet emits gamma rays from its own internal processes. Only the most extreme astrophysical objects do, like pulsars, black holes, or supernova remnants. Or, if this hypothesis is correct, cue balls. Now, let me be absolutely clear. The cue ball hypothesis is not mainstream science. Cue balls are a theoretical, speculative concept. The vast majority of astrophysicists would dismiss this idea outright as being too exotic. It requires us to accept that dark matter takes a form we have never detected, that the early universe produced stable, macroscopic quantum objects, and that one of those objects just happens to be passing through our solar system right now. The simpler explanation, and the one preferred by most scientists, is that 3I Atlas is just a very weird comet. It may have unusual chemistry, unusual dust, and perhaps a strange internal structure that we don't yet understand. But it is still a natural object, explicable within the bounds of common teleplanetary science. That is the position that most scientists hold, and they may very well be right. But if the anonymous leak is genuine, if there really is a working group within the European Space Agency that is struggling to make the data fit, then the cue ball hypothesis is likely being discussed, maybe quietly and behind closed doors, not as the definitive answer, but as the only alternative on the table that doesn't require ignoring half of the observations. And if its predictions hold true, if 3II Atlas stays bright as it leaves the solar system, and if our telescopes detect gamma rays emanating from it, then the entire conversation will change, and it will change very fast. This brings us to the next chapter in this unfolding story, because in just 26 days, 3II Atlas will do something that should make everyone, regardless of their position on its origins, just a little bit nervous. It will disappear. Not literally, of course. The object will still be there, moving silently along its trajectory. But from our perspective here on Earth, it will become completely invisible. It will be hidden behind the sun, swallowed by the blinding glare of our own star. This event, known as solar conjunction, will happen on October 24th. From that day until early December, we will not be able to see it, track it, or measure its position.